Hi everyone, we're going to find all local extreme values of the graph of f of x equals x squared times e to the power of negative x by using second derivatives. And we're going to take the first derivative, we're going to take f prime of x. Using the product rule, we'll take this first term and differentiate that, and you get 2x times your second term, plus copy down your first term times the derivative of your second term. So that's e to the power of negative x, and then you have to multiply that by negative 1. All right, so if you simplify this, what I'm going to do is factor out e to the power of negative x, and that's going to give me 2x minus x squared. So let's go ahead and set this to equal to 0 to find our horizontal tangents. And if you do that, we don't need to look at that. So we just really have 0 equals, and I'm going to factor out an x. So you factor out an x, and you're going to get 2 minus x. So we have at 0 our x equals 0, or our x equals 2. So we're going to be looking at those in just a minute. Now, let's go ahead and take our second derivative while we're at it. So f prime, double prime of x. So we're looking at this, and we're going to use the product rule again. Therefore, let's go ahead and take the derivative of our first term, which is negative e to the power of negative x times 2x minus x squared, plus copy down e to the power of negative x and differentiate this. This is going to be 2 minus 2x. All right, from here, let's go ahead and factor out e to the power of negative x. When you do that, I'm going to distribute this negative here, and you're going to get negative 2x plus x squared. And then for this piece, you're going to get plus 2 minus 2x. Simplifying, we're going to get e to the power of negative x, and this will be x squared minus 4x plus 2. All right. From there, turn my phone down. Okay, from there, we're looking at where f double prime of 0. So when I substitute in 0 here, I'm going to get, if I substitute in 0, I'm going to get just 2. Now 2 is positive. So now I'm using these critical numbers here. So now let's do f double prime of 2. Now when I substitute in 2, I'm going to get, I'll just write out e to the power of negative 2 times 2 squared minus 4 times 2 plus 2. This is just going to give you, this is going to be negative 2, and I'm going to move this in the denominator. So this is going to be e squared, which is negative. Now, when you use second derivatives, if it's positive, it means it's a minimum value. So we're going to have a local minimum value at x equals 0. Since this is negative, this is going to be a local max at x equals 2. And here's your graph. So I have a graph here, and at 0, and then we have 2. These are your critical numbers. So basically the graph looks like this. Something like this. Use a sign diagram. This is going to go at 2, something like that. All right. So basically here is your minimum value, and here is your maximum value. Again, what we had is f double prime of 0 equals 2. So that means this is positive, and that means this is positive on the right side of the 0. And then we had f double prime of 2 is negative 2 divided by e squared. That was negative. So you're always looking at the right side of the curve here is negative. That tells you, you look on the right. You have to be very careful with this, because if it's positive, it means it's a minimum, because you're looking at the curve on the right since it's going up. If it's negative, then it has to start up top here, then it has to go down. So just be careful with that. And there's the little graph. We didn't have to graph it, but there it is. Thank you. Have a nice day. Bye-bye.